Talokalama and welcome, boys and girls, to yet another episode of our program. Our subject area for today's program will be on agricultural science. Agricultural science for the levels Year 11 and 12 students. Our focusing strand will be soil. Soil. And our topic for today is titled Soil Texture. Soil Texture. Ia o le taimina nei, o le atu uina tulo le sunga ia te lema e nari, a wā le whaawa uina o le tatou le sona.
Soil texture. There it is on the screen is the definition of our topic, soil texture. The meaning of soil texture is a relative proportions of sand, silt, and clay in a soil sample. There are two ways to find texture of a soil. One method is by using the texture triangle. As you can see on the screen, the picture of a texture triangle. You are expecting to use this texture triangle with some of our calculation later in our lesson. Our first method is using the texture triangle. As you can see on the diagram, is the picture of a texture triangle. You are expecting to use this texture triangle diagram later in our lesson. So prepare yourself a texture triangle for our calculations. The second method is feel method, or rubbing between fingers and thumb. As you can see on the diagram, is rubbing the ribbon or soil particles with your finger and thumb to find the size of the particle. But for this lesson only, we are concentrating on the first method, which is using the texture triangle. This method, texture triangle, to find the texture of a soil sample. Remember, soil texture is sometimes referred to the size, finding the size of a soil particles. The three soil particles are mainly the clay, the silt, and the sand. Later on our lesson, we will discuss more about the three soil types: clay, silt, and sand. Clay is a soil particle of smallest size. O le clay, o le particle pito i la ititi a lea, e whaatusal clay i le flower mata, po o le pefu fo i le lea savili. Le la ititi ngā o le particle o le clay. Clay feels slightly sticky, e mase e see. Pe asusu, they feel smooth when a piece is rubbed between finger and thumb. E potopotoi fo i pea e no fo e mili lo lima, tai pe o le flower mata. O se ata whaataitai ngā o le palapala le ta o le clay. The next soil sample is the silt. The silt is granular material of a size between sand and clay. O le silt o le palapala lea e feo lolo longa size e le vā o le clay ma le sand. Sand is a soil particle of largest size. O le sand o le palapala pito I la poa lea lona particle. Rough and coarse e talatala. When feel between fingers and thumb e talatala pea e nofo e mili lo lima matua ma tamai lima. Ia o se e senga na o soil particle e tolu, clay, silt, sand, le la atala no ina le tatou le songa nei. On the diagram is the size comparisons of the three soil particles. As you can see, the clay starting from the smallest particle, clay, is invisible at this scale. Pea ona wha whaatalatala noa mua atu o le clay taipei o se pefu po se flower mata le laikiki o lona soil particle no inga e lewa ai o tatou mata pe a tū mai na o le particle le tasi. Lea o lo lunga I le fua o le clay o le la poa e la ititi for the 0.002 millimeter. A whaatusa la I le sealed. Seal lea skama dota I lalo I o longa size is 0.05 to 0.002 millimeter. That is the size of the sealed particle. And the sand, the largest particle of the three soil particles, which stand at 2 to 0.05 millimeter. O te lela le sand and the gravel, gravel o le maa e le la vela gravel I tatou soil particle le tolu. A o le whaatulanga mai I mo se whaatusatusanga. Next on the slide on the screen is a very simple experiment of how can I tell what my soil texture is. O le isi lea awala e su ele texture palapala. O le experiment whaingofia lea. This is a very simple experiment of separating sand, silt and clay within a soil sample. You can try this at home. To work out what your soil is made up of, put some into a jar of water, shake it up, and let it settle out. Ia, e tu'u e mua ne no fo o mai le pala soil sample le o mai e whaonga le zigzag method po le set method. Ona wha na sieve. Tam whai avane se wai vala e whaamama I ave e se maa ma meo taota malaula au. Ona avane la e o le soil sample le o tu tono le whangu. Le whaata tu ile ata le. The sand and large particles fall to the bottom. First, mark this level with a texture. Yeah, umarona na tu to tonu le whangu so sample sa ai ma le vai lu. Wa I lu ona seto la ia tu ulo le whangu I awani to e whaamingoin. Lea lai whai mai, the sand and large particles fall to the bottom. Umarole minute tasi. Na moa le ata le lui. Sand layers. E pitoa I lalo particle la po o le sand layer. Mafu anga ona mamafa. Leave the jar for a few hours. Check it again. This new level is the seal component. Mark this layer. Le luai tu la. Talo ona to e whata tia le whangu awa lava le whaaminoina. Ona form up mai leo le sealed layer. E latu le ata le pea le luai tu la. Now leave the jar undisturbed for 24 hours. When the water is clear, mark the top layer, which will show you the clay content. O le clay la, e tu'ula le whangu e whaamoea mo le lua sufai tu la. O le umina e seto tauna le clay, whatoa whai o mo le layer clay. E lua sufai tu la pe wha overnight. Ana mo miro le ata leo clay po le pefu e pito I lunga so o koe malsio pito I laro le sand. From the 3 marks on your jar, you can work out the percentage of sand to seal to clay and using the chart below. You can classify your soil. O le tatou experience mulmuli o le ato e wha lautele atu ai le tatou wata lea po le experiment mulmua lea le ato e kawa le tatou wata le experiment muli le follow mai le tatou le sona. Next on our lesson is a video clip called Soil Dynamic Video. This video clip is to distinguish among the sand, silt, and clay. This can help you understand more about features of the three soil types.
Particle size contributes to what type of the soil we're talking about. So this is a loam right here on the right side. So if we look at that soil, it's going to have varying sizes. We could go from very big like boulder to gravel, but eventually when we get to the level of the soil, we've got sand. Sand is going to be relatively large in the soil. We then have silt. And then finally we have clay. Clay is going to be particles that are smaller than 2,000th of a millimeter. So really, really fine particles. Now, what do those particles contribute to? It's the type of the soil and the porosity of that soil. So let's say we take those three particles and fill up a container with sand, silt, and clay, and then we fill it up with water. Well, you can imagine what's going to happen. In the container that has sand, it's going to drain out, or we're going to have high porosity. And that's going to take hours. In the silt, it's going to take days. And in the clay, it's going to take years. And so having a lot of clay can really stifle the movement of water into the pores where those roots need it. Now we can classify soil based on which of these particles we have. And so this chart takes a second to get used to. So this would be the clay on the left side from 0% to 100%. And this would be the silt on the right side and then the sand down below. Remember, in particle size, sand's biggest, then silt, and then clay. And so you can see on this chart that anything that has 50% or higher clay, we just call that soil clay. And we're not going to have good drainage, and this is not going to be a great place to grow crops. What's the perfect soil? Well, if we've got about 20% clay and we have about 40% of sand and silt, we have what's called a loam. And that's going to be a nice balance of all those particle sizes.
This is the diagram of a texture triangle. It might look confusing, but it is very simple if you understand the basics and follow the rules of a triangle, of a texture triangle. Jo le atala lea o tātou texture triangle. Lea wha lia tuai wha atatuai ia soil sample, I mean soil particle e tolu, clay, silt, and sand. Starting from clay, the smallest particle here on the left, right up here, there's the clay, the silt on the right, and the sand at the bottom, clockwise. Manatua e tu mau wale le pito le clay e le suia. Pena fo le silt ma le sand. Sand ai pito I lalo al clay ma le silt pito I lalo. Whaingo whiala na mamlama I le amata mai the smallest part, which is the clay, clockwise, ngālu re whatamila sanga le wati. Particle like titi, alu re whatamila sanga le wati o clay, so atuai ma le silt te whanolo, pito I lalo, o le sand. Ona iei taimi e avatu ai le diagram, ai le label, e le o avatu ai le o label ina ia party e tolu. Whaingo whiala ia unga e memorize ma understand, ia vaenga umai tolu le triangle. Directions of lines. Directions of lines representing each soil are very important. As you can see on the triangle, the clay line is laid horizontally. O le clay ia e whaalava I lalo le direction o lona laina. Lea, clay ia e pito lea e whaalava e lesu I asa direction o clay ia horizontal. Mai tau le clay le pito lea o lona direction o laina e horizontal, whaalava o le siu le piko lea o le direction o lona laina e sauna I lalo I diagonal, from right to left downwards. Ne sauna I lalo I e lesu I as direction. O le sand at the bottom here, the direction o lona laina, right to left upwards. Ne o ngā form up ai la I o le start, whitu. Paingo fie o ngai malama ma memorize I le direction o laina o soil taitasi. Ona iei taimi e le label ai. Ai te nofua o e create ma label according lo malama na we. When connecting the three lines, it forms a star as you can see on the triangle. But for the boundaries of texture class inside the triangle, they are fixed as it is. O boundaries po tua oia le poudaku e vai lua ai le texture class mai le isi texture class. Whataita inga o le shield le I, tuli manua ia le o le shield, o le tuli manu le o le clay, tuli manu le o le sand. E le sui ai tu maua. Texture class la le whailonga le pod, o na o mai role e le isi class le o le sealed loam. Ma le loam lea e o ngā tonu I. Remember, manatua le loam is a soil type from the combination of the three soil type, of the three soil sample. Tu whaatasi le clay, sand le seal, combine, plus the organic. O na maua le o le soil le ka o le loam. O le loam is the most fertile soil for agriculture and corn crops. O le loam la, o le palapala pito I le leilea mo le stoino la au. O le sandy loam le si class lea. Sandy and loam means the mixing of sand and loam. Ai te lea I ale sand. O na o le pito I luma sand e pito I tua loam. Also, this clay loam is a combination of clay and loam. Ai ke leel pasang no clay ala titi loam o na le pito I luma le upu clay. Next is our example. Our example is to determine the soil texture class using the triangle or the soil triangle. For this example, a soil A has the following percentage of soil separate: the sand 65%, the seals 25%, and clay 10%. Remember, all these percentages must add up to 100%. Afa popo fatasi percent neo sand seal clay tau ona maua le salau ona sawale tuol facili. What is the texture class name? Refer to the texture triangle. Next slide. Yeah, la fa nga lo kako texture triangle. It draw eye lines o soil particularly at sand seal clay. By using the texture triangle to draw where the line of each soil meets. So here is the texture triangle, and we use the number and the percentage of sand, seal, and clay to find out texture class. The sand is 65, so the sand is down here, 65 is somewhere around here, 65, and we are expecting the line at this point. Yeah, there it is. Remember the direction of the line. Sand comes from left to right upwards, like this. And for the seal, this is the side of the seal. 25% is here, and the line starts from here downwards. Yeah. The clay, this is the side of the clay. Clay is 10%. Here is 10%. So our line draws from here. There. So there it is. The question is, what is the texture class name? What is the texture class name? Yeah, that's of Talile. The texture class name is the sandy loam. By using texture triangle to draw where the line of each soil meets, we can see that all the line meet at the sandy loam class. And this is the texture class for the problem. So that is our example. And for the next part of this lesson, you will watch a video clip about more examples of soil texture calculation.
So in this video, we're going to learn how to use a soil texture diagram, or it's called a soil triangle, to determine the amount of sand, silt, and clay in a soil sample. So at the bottom of this sheet, we have a table. The table has the percent of each sand, silt, and clay, the texture name, and then the properties of that clay, which are dependent on the different types of minerals that it has. So for the first example, we have 75% sand, 10% silt, and 15% clay. Now remember, if you add sand, silt, and clay, it makes loam. So it makes sense that that would be sandy loam. But you could figure this out by going, here's the percent sand. So there's 75% of that. So here's 100%, here's 70, here's 80. And there are two lines. There's one that goes on the left, and there's one that goes on the right. So you're going to figure out 75, you're going to go in between 70 and 80, and you're going to go towards the left. So in between 70 and 80 is about right here. And you will just put a little, you can use a highlighter if you'd like. You're going to go in between the lines that are 70 and 80. 70 and 80. Then you're going to go figure out where's 10% silt. So you'll find the silt line, move the paper. So now you see that's 10% silt. So anywhere along this line is 10%, 20%, 30%. So you're always going to look at the line on the left. Okay. So we're looking for 10% silt. So we'll take our highlighter and we're going to highlight 10% silt. And where these two lines intersect, that should be where your clay is. So if we go to clay, you want to turn it to the clay side. All of this is 10%, 20%, etc. So it looks like between 10 and 20 is 15%. It's 15% clay. And indeed, that was 15% clay. So that's where we got sandy loam here. So let's do the second one together. Got 10% sand, 83% silt, and 7% clay. So we're going to go to the sand. We're going to go find 10% sand. So it's going to be somewhere, and I might use a different color. You can start off with a few different color highlighters. Remember, I told you to go the line on the left, not the right. Now we're going to go to 83% silt, so you can turn it to the silt side. And you will find the 83. Here's 70, here's 80, here's 90, and you're going to go to the left. So 83 is probably closer, a little bit closer to 80. Okay, and so far we could figure out just based on those two that it's silt, but let's double check. 7% clay, so we're going to go to the clay part, face it towards you to where this line is towards you, and we're going to go to, here's 10, here's 5, so we're going to go to 7. So 7 would be about probably between 10 and 5. So we're going to just kind of make a line here, and indeed, boom, we're going to write silt here. Okay, so if you look at this table here, silt has medium nutrient holding capacity. It filters water pretty good. It can hold water pretty well. Aeration is the amount of pore space, so it has pretty decent pore space, and it's moderately easy to work with. So I would put properties, under properties, pretty good all around. So now let's look at this third example, C. 42% sand, we're not sure how much silt, 37% clay. So to figure out the amount of silt, the whole thing has to add up to 100. So we'll add these two together, 42 plus 37 is 79. 100% minus 79, so that's 21% silt. So let's start with the sand, 42% sand, and I might use a blue one this time. So here's sand, 42% sand. So 40, 50, and remember I'm always looking at the line on the left. So 42 is going to be fairly close, somewhere along that line. 21% silt. So I'm going to go over to the silt and go to 20. Always look at the line on the left. There's 20, there's 30, so 21 is probably going to be close, really close to 20. And I could mark this right here, and it would be classified as a clay loam, but before I totally feel comfortable with that, I'm going to double check to make sure my clay matches up to 37%. I'm going to situate it so clay is directly in front of me, and then I'm going to find here's 30, here's 40, and I'm looking at the lines on the left. So 35 is probably in the middle, so 37 would be about right here. And so where all three of those intersect would be a clay loam. And clay is pretty good because it's negative in nutrients. A lot of the nutrients are positive. It's good nutrient retention.
More exercises is coming here on this table. This is where you will need to take a photo of this table. Use your cell phone to take the picture of this table, this exercise, because we don't have enough time. And for you to use your texture triangle class, because I believe some of you do not have your texture triangle class with you. So when you find your texture triangle, use this table to calculate the texture class. So by filling the missing gaps, the zeal, and the texture class for the first part. So for the sand, 34, zeal is missing, clay is 33, and the texture class is missing. So how to find the zeal is at 34 sand and clay 33 minus 100. That 100 is 100%. Then find that is the 0%, and you use the texture triangle just like our example we've done, and more example from the videos to find the texture class. And the second part, the percentage of soil type is given. 43 sand, seal 50, clay 7. So all you need to do is use the texture triangle, plot the line to find the texture class. And also for the other activities follow, sand is unknown, seal is 10, clay is 30, and also find the texture using the texture triangle. And these are the answers from our previous table, our previous activities. Take a photo of this table, use your cell phone. You can check your answers from this table if you have spare time. Our summary activity and our last activity is a soil sample was taken from a farm and placed inside a cylinder, then filled with water, shook it vigorously, and left it standing overnight. The next morning, it was settled as shown in the diagram. Just like our previous experiment, our first experiment, lea ua iele palapala I tatonu o le whangu sa ai ma le vai lu settled for overnight. E umane ua maua le sand, fast 4 mm, seal 4 mm, 45 mm, clay 25 mm. Total up maua le values per millimeter. And the question, use the diagram, use the information from the diagram to A, calculate the percentage of clay, silt, and sand in the soil sample. B, find the texture class of the soil sample. Just like our previous example and activity, calculate the percentage of clay, silt, and sand. Remember, the total percentage is 100 and the total millimeter is 80. You add up 40, 15, 25. What will be your answer? Use the percentage and draw the line using the texture triangle. What will be your answer? And the answer is shown on the diagram. 25 for clay, 25 divided by 80. Remember, 80 are the total millimeter. Percent is 31.25% for clay. The silt is 15 divided by 80 times 100 is equal to 18.75%. And for the sand, 40 divided by 80 times 100 is equal 50%. Draw these line on the texture triangle, plotted line on the texture triangle using the percentage. For the clay, this side is the clay, 31.25. Clay, here's the line for clay. The silt, 18.75, somewhere around here. Silt here. And the sand down here, 50%. There it is. All intersect and meet at sandy clay loam. And our answer for part B, find the texture class of the soil sample, and the texture class is sandy clay loam. And that's wrap up our lesson for today. Thank you very much for your concentration. I hope our lessons give you more understanding about soil texture and how to find texture class using texture triangle. Until then, 做花水父。